Hi, and welcome to the video for sections 2.3 and 2.4, where we're going to be talking first about measures of the location of the data. So in order to look at the measures of the location of the data, the first thing we're going to talk about is calculating quartiles and percentiles. In order to do this, we first need to make sure we have ordered the data from smallest to largest. And then quartiles will divide the ordered data into fourths or quarters, and percentiles will divide the ordered data into hundredths. So let's start by finding the median. This is the middle item on an ordered list. So here's my ordered list. It goes from 18 to 77, and this list has 29 items. So halfway through this list will be the 15th item. We'll have 14 items. So here's the first 14 to here, you can count. And then we have the number 47, and then we have the last 14 items. So there's 14 ahead of this one and 14 after, which makes the median 47, or the middle item on the list. If your list has an even number of items, you will just pick the middle two items because there won't be a specific middle one, and then average that value. Now that we've found the median, we can find the quartiles. So if we look at the first half of the list, so this is up to the median, it goes from 18 to 42. When we divide this list in half, there are 7 items on each list. There's 7 items here, and there's 7 items here. So there is no exact middle item. So because this is a list of 14 items, so there's 7 and 7. So the way we find the quartile is we average the two middle ones. So 29 and 30 average to 29.5. That one's pretty easy to find the average, but don't remember you can always add them and divide by 2 if it's a little bit harder to find the average. So that gives me 59 divided by 2 is 29.5. All right, why don't you try to find the median, the third quartile, which is the median of the second half of the list. All right, the list is already divided into 2 values for you. Did you pause the video and find it? We need to average 67 and 69. 67 plus 69 over 2 is going to be equal to 6. Carry the 1, 136 over 2, which is equal to 68. So my third quartile is 68. So 1/4 of the way through the list is 29.5. Halfway through the list is 47. 3/4 of the way through the list is 68. We can organize this data into something called the 5-number summary. The 5-number summary for data tells you how spread out data is, or how condensed data is. And the values that go into the 5-number summary are the smallest value, the minimum, the first quartile, which we often refer to as Q1, the median, the third quartile, which is Q3, and the maximum. We actually sometimes refer to these guys just as Q0, Q1, Q2, Q3, and Q4. Q0 mean the 0th quartile, that's your minimum. 1/4 of the way, 2/4 of the way, 3/4 of the way, and 4/4 of the way. So in our example, the 5-number summary is 18, 29.5, our median of 47, 68, third quartile, and the maximum value of 77. One other thing we like to look at is the interquartile range. So the interquartile range is computed by subtracting the first quartile from the third quartile. So our third quartile was 68. Our first quartile was 29.5. You subtract those two numbers and you get 38.5. The interquartile range tells you how much space is between the first and third quartile, and it can give you a comparison to figure out how spread out data is. Let's go to Desmos and practice doing some of these examples, not by hand, but by using technology. So let's go ahead and go to Desmos. You'll find the link for this data already in the Desmos. If you go to the My Open Math page, there'll be a link right below this video. All right, so what we're going to do now is we're going to go to Desmos and use it to help us do some computations. So if you go to where you open the video is right here, and it says here's a link to the Desmos data. So go ahead and click that, and that should take you to this Desmos page. So once you get there, you can see in the left-hand column all the data, 18 through 77 that we had before. And we're just going to use Desmos to learn how to calculate the median and the quartiles. So what we're going to do is we're going to get this out of our way. Maybe we can move this over here. There we go. Nope. There we go, because we need the little keyboard button down there. So what we're going to do now is we're going to go to the keyboard. We're going to click in box number 2, and then we're going to go to the keyboard, and we're going to go to functions. And the first thing we're going to do is we're going to choose median. Okay. So median, and then it's like parentheses, and it says, what do we want to take the median up? Well, all of our data is in this column, and the name of the column is X1. So if we type in X1, it'll know that we're talking about this column of data, and it will give us our median value of 47. Right? So that was the same median that we got when we calculated it by hand. Let's try this with quartiles. Again, we go to functions, you go down to the statistics, and you see where it says quartile. And again, we want a quartile of the data in the column X1. Quartile needs two things to enter, two arguments. It also needs to know what quartile you want. Do you want the 0th quartile, the first quartile? Let's go ahead and find the first quartile. So the first value that you put into quartile is the name of the column of data. In this case, it's X1. And the second thing you put in is what quartile you're interested in. And then we put in 1 for the first quartile, and they gave us 29.5. If we want the third quartile, we can go back and change that to a 3, and it's 68. If we want the fourth, which is also the maximum, that gives us 77, or the min, which is 18. Do them all this way. So you know how we refer to the quartiles as Q0, Q1, the 5-number summary is Q0, Q1, Q2, Q3, Q4, whatever. So we can do that with Desmos as well to find all the quartiles. All right, so let's go back to our and talk about a few more things that we're going to learn how to do. So now that we know how to find quartiles, let's make sure we know how to interpret them. So let's look at an example. Let's say we had a timed math test, and the first quartile for time it took to finish the exam was 35 minutes. So interpret the first quartile in the context of this situation. So we wrote down the times of everybody taking the test, and the very first quartile was 35 minutes. So what does that mean? Well, it means that 25% of students finished the test in 35 minutes or less. The first quartile tells you from the smallest amount of time up to the 25th quartile. So 25% of the students fall into that category. 75% of the students took longer than 35 minutes to finish. Remember, it breaks into 25ths. So if we were thinking about the list of data values, we don't know what they are. We have some data, and then we get to the 25th percentile, and that value is 35 minutes. And then we go along and we have a lot more up here, right? So 25% of the data is in here, and 75% of the data is more than that. Oops, I meant to write a 7. If it was the median, we would say 50% was below and 50% was above. Let's talk about percentile. Remember, percentiles divide data into the 100s. If you score in the 90th percentile on an exam, that does not mean necessarily that you received a 90% on a test. You may have, you may not. It means that 90% of the test scores are the same or less than your score, and 10% of the test scores are the same or greater than your test score. So, for example, if you're, they're always, when you have children, they always tell you, oh, your kid's in the 70th percentile for height. That means that child is taller than 70% of the other kids and shorter than 30% of the kids of the same age. So to make sure we understand this, let's do a quick example. I want you to pause the video and figure out which of the following statements are true. On your chemistry test, you scored in the 30th percentile of the class. So go through each of these and decide which one of these are true and which ones you don't know are necessarily true. All right, did you pause the video and give this a try? Let's go through it together. If you scored in the 30th percentile, you got a 30% on the test. You may have, but we don't know that for sure. You do know that you scored a higher than 30% of the class. Okay, here's the class. Here's the 30th percentile. That's you. Here's the rest of the class. There's 30% here and 70% here. Okay, that's you. So you didn't score lower than 30% of the class. You didn't score higher than 70% of the class. You scored lower than 70% of the class. As for you definitely failed this test, maybe, maybe not. Maybe people did great on this test, and the 30th percentile was like a 80% for all we know. There's no way to come back with your test score just based on your percentile. You would need more information. So you can't say you definitely failed or you definitely passed. All right. So a graph that we use for the 5-number summary and for showing us our quartiles and median is called a box plot. A box plot, sometimes people call them a box and whisker plot. It gives us a good graphical image of the 5-number summary. So a box plot is constructed from the 5 number summary values. The first value is the minimum value, and you'll see that right here. That's this left wing. The next one is the first quartile, so we draw a bar here at 2. The median is drawn with a dashed line here at 7. The third quartile is up here at 9 on the right side of the box, and the maximum value is the final whisker. You draw a box from Q1 to Q3, and then you extend your whiskers out to the max and the min. All right? We can use these to compare different data sets and how spread out or how close together they are. So if we look at this example, our min was 1, our Q1 was 2, our median is 7, our Q3 is 9, and our max is 11.5. Let's learn how to make box plots on Desmos. We're going to go back to that same file that you had open before, and I'm going to bring it down here if I can find it. Here we go. Here's the same file that we were working in, the 2.43 lecture example file. And you can leave the quartiles and medians here if you want to, or you can get rid of them. Just don't get rid of the data. If you do, you can always go back and reopen the data file, and it'll go back. You guys can't save this, so it'll go back to the original way. So we're going to choose, go to our menu, go to functions, and instead of going to statistics this time, we're going to go down to visualizations, and we choose box plot. And enter the data set. Well, we're going to tell it again, the data still is in the column X1. So there we go. And we don't see anything right now, but that's because the window we're looking at isn't good for this data we're looking. You can scroll around and try to find it. Or a really quick way is to see this magnifying glass with the plus. Click that, and it gets you a zoom fit and gets you a really nice picture of the box plot. So there's our box plot, and then you can move it around as much as you want. Pretty slick and easy way to do box plots using Desmos. So again, let me go through that one more time. It's just into the showing the keypad, and then you go to functions, and then you just scroll down to visualizations, and you can find box plot. Let's take that away. All right, so let's learn to interpret box plots now that we know how to read them and we know how to make them. Here are 2 box plots that compare sales of wristbands at 2 different stores over a series of days. Store A is here on the top in blue, and store B is here on the bottom in green. I have 3 questions for you. I'd like you to pause the video right now, try to answer these questions, and then unpause the video and we'll go over them together. All right, are you back from pausing the video? Which store sold more wristbands? I probably should have put this one first because this one you don't know, right? You don't know how many wristbands it's sold. We just know how many they sold each day, but we don't know number of days or anything like that. So we're unable to tell the answer for that one. So maybe I shouldn't have put that one first. It was kind of a trick. Which store has the most sales on a given day? Well, which one has the highest maximum value for a day? Well, this one is store A. It looks like it's right about maybe 76 or 77. So store A has the highest sales for a particular day. The minimum for sales for store B, so that's this value right here. That's the minimum for store B, is about equal to what percentage of sales for store A. So it's not exactly, it's a little less. Let me draw on this. Here, it's a little bit less, but if we just say about, well, the minimum sales for store B is about at the median for store A. So the median, right, would be, this is our median right here in the middle of our box. The median is 50th percentile, so it's about 50%. About 50%. All right, that's it for this video. I hope you found this helpful, and go now and do the homework assignment.